In today's class, I am going to discuss projectile motion from a height. So what exactly is this projectile motion from a height? To know that we have a tower or a building of certain height and we throw a ball from the top of the tower at different angles, or the different angles can be given as case 1, case 2, case 3. So let's see what exactly is this case 1, case 2, case 3. So in case 1 we have a tower. At the top of the tower I will be throwing a ball in with a velocity u in the horizontal axis. For the purpose of explanation, I am dividing the top part of the point where I will be throwing the ball as positive y axis and below as minus y axis. And similarly in the right side of the direction I am writing as positive x axis and this is taken as minus x axis. So these are the two things we have. Now what I am going to do is case 1, case 2, case 3. What I will be doing is, in this case 2 I will be throwing a ball with a velocity u, making an angle theta with the x axis. Here I make an angle theta with the x axis. Here I am throwing the ball in downward direction. Here I am throwing the ball in upward direction. Now let's discuss each case in detail. In case 1, what I am going to do is I am going to draw a tower. This is the top of the tower of height h, and let's take this to be the vertical axis. This is plus y, this is minus y, and here this to be plus x axis minus x axis. So here I am going to throw the ball with a velocity u in the direction of positive x axis. So the ball goes like this and comes down and touches the ground. So here you can clearly observe this is the range of the projectile. Now let's discuss the parameters involved in this situation. So I am throwing the ball at t is equal to 0. Now what you can observe is, let's take ux. What is ux? Ux we have discussed in our previous class as well. Ux is the component of velocity in the x axis. Now just see, the velocity is moving in the x axis itself. So by the formula that we have discussed so far, ux is equal to u cos theta, and what is theta? Theta is 0 degrees because it is in line with the plus x axis. So it is cos 0 degree into u. Finally the value is u. Now what about uy? Uy is, do we have any velocity in the plus y axis? This is the vertical axis. We don't have any velocity component in the vertical axis. So what is the value? It is 0. Now coming to the next part, sy. Sy is what? Sy is the displacement of the ball in the minus y axis. So you can write it as minus h. Why am I writing it minus h? Because the displacement is moving in the minus y axis. Now coming to the sx. What is sx? Sx is the displacement of the ball in the horizontal direction. Ultimately that is equal to the range. Now let's see the next part, ux, sy. Now what is ax? As we know, there is no air friction involved in this case. We can clearly tell ax is equal to 0. On the other hand, ay is what? Ay is responsible, or the acceleration that is moving in the acceleration that is pulling the ball in the negative axis is responsible for the ball to come to the ground. So it is minus g. So we have got the three parameters. Now let's calculate the time of flight and range. We use equation of motion for that. So I'll use the equation s is equal to ut plus half at square. Now let me substitute this in the y axis component. Sy is equal to uy, t is time of flight, plus half ay t square, this is time of flight. Now what is sy? We have already discussed sy to be minus h is equal to uy is 0. Why 0? Because initially there is no velocity in the plus y axis. So it is 0 into t plus half. Ay is what? Ay is minus g into t square. So let's solve it. Minus h is equal to 0 into t is 0, minus half gt square. So time of flight is 2h by g root 2 h by g. Now it's very easy to calculate the range, because we know range formula is, from this scenario, it is ux into t. What is ux? Ux is the component of velocity in the horizontal direction of x axis. That is, ux is u cos theta. However, theta is 0, so we can write it as cos 0. It is u into t. What is t? T is time of flight. So finally range is u into 2h by g. So this is the final value. Here theta is equal to 0 and the cos theta is 1. So this is the case 1. Now let's discuss the case 2. Now let me take the second case, where I will be drawing a tower. I have a tower. Now what I am going to do is, I am going to throw this ball from the top of the tower with an angle with the horizontal. Let me divide this into two components, that is x component and y component. Let me do that. Let the top of the tower indicates plus y coordinate system, this is minus y, and let this indicates plus x and this is minus x. Now what I will be doing is, I will be throwing a ball with from the top of the tower with a velocity u in the direction, as you can see, u, it takes in this path and it falls here. So here it is making an angle theta with the horizontal axis, 90 minus theta with the vertical axis. Now let us discuss the parameters. That is, this is the range of the projectile, and I will be writing it as u x. This is velocity. Let me take this velocity. Ux is equal to what? U cos theta. What is this? This is the initial velocity. Now coming to uy, what is it? U sin theta. Why am I writing u cos theta and u sin theta? Because this is u, I am throwing the ball with a velocity u, it is making an angle theta with the horizontal axis, and 90 minus theta will be y axis, plus y axis. So you write the velocity component. Now coming to the displacement part, Sx is what? Sx is of course the range, the final range in the positive x direction range, and we have to calculate it. Then Sy of course you can see it is the height, total height of the tower in the negative direction, so it is minus h. Now coming to the next part, it is acceleration, Ax. It's very clear that I am not going to apply any acceleration on the ball throughout the journey in the positive x axis. So this is 0. Ay is what? Ay is the acceleration due to gravity that is responsible for bringing the ball from this point to the ground position. So it is minus g. Now let's apply the equation of motion and find out the time of flight and range of the projectile. Applying equation of motion, s is equal to ut plus half at square. So how should I calculate? It's very simple. Let me take the y component of it. Sy means that is the displacement in the y direction, and this is uy, t is time of flight, plus ay, this is ay t square. We clearly know Sy is what? Minus h, and uy indicates u sin theta t. Now the one important aspect you should like to see, that u cos theta is in the positive x direction, u sin theta is in the y axis. So you write this as, so that's the reason I am writing plus u sin theta. Then here ay is minus g, so we get it as 1 by 2 g t square. Now this is the quadratic equation. Solving it, you will be getting the value of t. Now how do you get the range? Range can be calculated by r is equal to u x t. It's very simple. Range is equal to, we know ux is given by u cos theta into time of flight multiplying time of flight, which can be calculated by solving the quadratic equation. So you get this in this manner. Now let's see the case 3, how to solve it, and it's quite similar to this format. Let's solve it. In case 3, what we are going to do is, we'll be taking a tower. From the top of the tower, we'll be throwing a ball in the downward direction. Let me draw the tower first. So this is the tower of height h, and this is the ground. Now for the purpose of calculation, I'll be dividing it into coordinate system. So at the point where I'll be throwing the ball, above it will be plus y-axis, and below this is y-axis, this is minus y-axis, and anything in the, this is plus axis and this is minus x-axis. Now what I'm going to do is, as per case 3, I'll be throwing a ball in the downward direction. Let me do that. So I am throwing the ball like this. So this is u, and it is make an angle theta with the horizontal. So this is 90 minus theta. Now let's see the various parameters. So ux is what? Ux is u cos theta. So here it is making an angle theta with the positive x-axis. Now coming to uy, it is minus u sin theta. Why it is minus u sin theta? Because it is 90 minus theta and it is in the negative y-axis. Now coming to the displacement, sx is, of course, it is the range of the projectile. We can write, we will be calculating its range. Now coming to sy, what is sy? Sy is the displacement in the negative y-axis. So it is minus h. Now let's see the next thing. We'll be calculating velocity, displacement and acceleration. Ax is what? Ax is constant, that is, it is 0. There is no acceleration in the horizontal axis, so it is 0. So who is responsible for the ball to get it down? Yes, I am throwing it with a velocity u, and of course apart from that, it is the velocity, it is the acceleration due to gravity that is responsible for the ball to come to the ground. So ay is equal to minus g. Now by using equations of motion, I will be calculating s is equal to ut plus half at square. Now what is this? S is, I will be using sy is equal to uy, t is time of flight, plus half ay t square. So sy is what? Minus h is equal to uy is, you know, minus u sin theta t. This ay is minus g, so it is 1 by 2 g t square. Now this is a quadratic equation. By solving it, you will be able to calculate the time of flight. Now to calculate range, it's quite simple. Range is equal to uxt. Generally these type of, while solving problems, it will be easy to do the quadratic equations. Here it will be a little bit complex, so I am directly telling that for range, calculating ux is equal to t, then ux is what? U cos theta into time of flight, that you get by solving the quadratic equation. So this is the basic theory behind the projectile motion from a height. Now let us see the next concept, projectile motion in a moving platform.